Good morning, good afternoon, and good evening. Hopefully one of those times fit when you watch this video / presentation. My name is Adam and I was working on the unit circle to see how it not only works with us with how we use it for the trig functions in Pre-Cal, but also how it's going to translate over to trigonometry once you get into that class as well. It is a pretty simple / complex thing that we're going to learn about, so buckle up and let's learn some things. So what is the unit circle? Well, that's a great question. I'm so glad you asked. So we are going to try to get a better understanding of what the unit circle is, and Khan Academy does a really good video on it that kind of helped me a lot. One of the basic ideas of the unit circle is that when we define the word unit, it means one. So when we're looking at a Cartesian graph, we know that it is going to be with the unit number of 1, so that kind of helps you kind of put it into play. What we're going to do here on these slides is talk more about the unit circle itself, and this is going to be something that we're going to slowly build onto, and then you just kind of add from there. That way it doesn't also get so kind of frustrating and for me at least overwhelming sometimes when you see it all in whole. If you do it piece by piece, it kind of helps. So what we're going to do is we're going to define what the unit circle is, the basic properties. We're going to look at the coordinates and the points. We're going to look at the trigonometric functions. We're going to look at the quadrantal angles. We're going to look at the radians and degrees. We're going to look at some applications, and we're going to look at some identities and formulas. And then, of course, we're going to have those practice problems because practice makes better. Also, I did make a visual aid, so we will go over that, and it is a little 3D thing that I had printed at the robotics lab, which is a pretty cool place to check out if you haven't checked it out yet at Sandjack. I highly recommend looking at the different things that they have there. If you ever need something printed, go for it. It's pretty cool. And what I did is kind of have the unit circle so you can physically see it and kind of manipulate it, move it around, and it helps you kind of learn the different functions that are on there, and it lets you see the cosine and sine, and it just helps you kind of put it into play to make it make more sense. So now we're going to go ahead and define what the unit circle is. So let's go ahead and do that. So the unit circle's definition allows us to extend the domain of sine and cosine to all real numbers. The process for determining the sine, cosine of any angle, theta, is as follows. You're starting from 1, 0, and then you will move along the unit circle in the counterclockwise direction until that angle is formed between your position and the origin. And the position of x-axis is equal to theta. And then with sine theta, it's equal to y-coordinate of your point, and cosine theta is equal to the x-coordinate. The other trigonometric functions can be evaluated using their relation with sine and cosine, and it will make a lot more sense when we see it a little bit more into play. You can also kind of see it right here in this graphic where it's kind of moving around, just like we were talking about. Now, we want to get into the basic properties first. You do want to have a better understanding with the radius of 1. So the unit circle has a fixed radius of 1 unit. Again, like we talked about just a bit, we said that a unit means 1. So that also kind of helps you see that. Its equation is x squared plus y squared is equal to 1 in the Cartesian coordinate system. So we also have the coordinates on the circle, and the points on the unit circle have coordinates. So you have cosine theta, you have sine theta, where theta represents the angle formed by a ray from the origin, which is 0, 0. And that's always where our theta is going to be located. And we measure counterclockwise from the positive x-axis. And when you go clockwise, it would be negative. We also have the trigonometric function relationships, and that's the x-coordinate and cos theta, and it's the cosine theta, corresponding to the cosine of the angle theta, and the y-coordinate, sine and sine theta, corresponds to the sine of the angle theta. We also have special angles, and it helps visualize and understand the trigonometric values, and that's the sine and cosine. So we have the special angles, which is going to be 0, which is our starting point. And then we have 30, 45, 60, and 90. And those are going to be our basic ones that we want to build on from. And those are going to start on quadrant 1. And it's broken down into 4 different quadrants, just like it is normally in the Cartesian coordinate system. We also have radians and degrees, and it aids in converting between radians and degrees as 1 completes the revolution around the unit circle. It's 360, so half of it would be 180, and then the other half would be 2. So a whole revolution is going to be 2 pi radians. We have the Pythagorean identity, and the equation is going to be x squared plus y squared is equal to 1. And it's kind of something that you can kind of translate a little bit with the Pythagorean theorem, a squared b squared equals c squared. And for the unit circle, it represents the Pythagorean identity in trigonometry, and that's relating to sine and cosine functions. And understanding these properties, it really helps you visualize and comprehend the relationships between the angles and the trigonometric functions and the geometric shapes. It makes the unit circle a crucial tool in trigonometry, and it's really something that is a good foundation to get started in, and you build from there. So you really want to take it and make sure you understand it so that you can make sure you go forward without those missing building blocks. So now going on to the identities, we do have the Pythagorean theorem, and the Pythagorean identity, it's the consequence of the Pythagorean theorem. So it states that sine squared x plus cosine squared x is equal to 1 for all values of x. This identity is derived from the right triangle in a unit circle. And another thing to kind of note from the unit circle is it doesn't work if it's not a 90-degree angle. It definitely falls apart. So these only make sense if it is a 90-degree angle. We also have the reciprocal identities, and in the unit circle, these values are going to be theta is equal to y, 1 is equal to y, and theta is equal to 1y. These two functions, by definition, are reciprocals, which just means flips. Therefore, the sine value of an angle is always the reciprocal of the cosecant value, and vice versa. Then we have quotient identities. On the unit circle, sine theta is equal to y, and cosine theta is equal to x. Divide these equations, and the reciprocal is also true. And then we have the even and odd identities. The even functions are cosine and secant. And then we have the odd functions, which are sine, cosecant, tangent, and cotangent. A function is even if it's symmetric with respect to the y-axis and has the property that if f minus x is equal to fx, a function is odd if it has the property that is f minus x minus f of x, and that's an odd function, which is from the origin. Then we have the cofunction identities. The first two cofunction identities, they come from the unit circle. The 6 main cofunction identities are cosine. You have theta, which is equal to sine, 90 degrees minus theta. And then we have sine theta, which is equal to cosine, 90 degrees minus theta. And then we have tangent theta, which is equal to cotangent, 90 degrees minus theta. And then there's cotangent theta, it's equal to tangent, 90 degrees minus theta. And then we have secant theta, which is equal to cosecant, and then it's 90 degrees minus theta. And then we have cosecant theta, which is equal to secant, 90 degrees minus theta. Now we're going to work on some problems. So this will kind of help you see how to use the unit circle and kind of give you an idea of how it works. So with this first problem, given the angle of 5 pi over 6, you want to determine the exact value of sine and cosine. And going to the next slide, we can see the solution right here. So for 5 pi radians, the cosine is going to be the 5 pi over 6. This angle is in the second quadrant, which again we have 4. So we do have the quadrant 1, everything's going to be positive, and quadrant 2, we're going to have, you have the mnemonic, the all students take calculus. So 1 is going to be all positive. Students is going to be sine is going to be positive. T is going to be tangent is going to be positive. And then C is for calculus. That's going to be cosine is going to be positive. So this angle in the second quadrant, using the unit circle, the x coordinate for this angle is negative the 3 square root over 2. And for sine, 5 pi over 6, the y coordinate for the angle is 1/2. So cosine is 5 pi over 6 is equal to negative square root of 3 over 2. And sine, again, is going to be 1/2. Alright, so I got another problem here. And for this one, if sine theta is equal to 3 over 5 and theta is in the second quadrant, determine the exact value of theta. So we're going to go ahead and go to the next slide, which is going to be the solution. So given sine theta is equal to 3 over 5, the angle is in the second quadrant, which again, second quadrant is S is going to be positive, which is going to be sine. The cosine theta will be negative. Using the Pythagorean identity, we have the cosine squared theta plus sine squared theta is equal to 1. And as we break that down, we just kind of do a plug and play here, and we go all the way down and see that once we go through the process, we see that cosine theta is equal to negative 4 over 5. Therefore, cosine theta is going to be equal to negative 4 over 5. And this is going to be the last question. So for this one, we have tan alpha is going to be equal to negative 1 over square root of 3. And alpha is in the fourth quadrant. Determine the exact value of secant alpha. So looking over here at the final solution, we see that tan alpha is equal to negative 1 over square root of 3. And it implies that tan alpha is equal to negative sine alpha over cosine alpha. Since alpha is in the fourth quadrant, both sine and cosine will be positive. Hence, sine alpha over cosine alpha is equal to negative 1 over 3 square root. 1 over cosine alpha is equal to negative 1 over square root of 3. And cosine alpha is equal to negative square root of 3. Now, secant alpha is equal to 1 over cosine A. It's equal to negative 1 over square root of 3. This right here is the visual representation that I had actually made. I'm going to just pause it for just a second. So this helps you see the difference of the sine, the cosine. You can see all four quadrants here. Once I hit play, I actually did this at the robotics lab in San Jac, and it's a pretty cool place if you haven't checked it out just yet. They have several 3D printers, and they have a lot of cool different things that you can check out there. It took about a week to get this one printed. With this, you see sine, you see cosine, and then you can see all the special angles. And then on the edge of it, you'll also see the coordinates for those special angles. So with the 30, once we see it, I'll show you the special angle for that one. And when you move the dial to the dot, you'll see the special angle that you're going to be on. You'll also see how the angle is represented. And once you move the dial to the dot, you'll see the coordinates, and then you can move your cosine and sine, and you'll be able to see how it's represented as well for your sine and cosine. So it's a pretty neat little thing here. Also, I did create some NFC tags for it, and you'll see that on the second video. And you can see the different links and things that are placed on there. You can tap it with your phone if you have the NFC on your phone activated, and we'll go over that in just a bit. Going on here on the second video, you can see the NFC tags being used. You just hover your phone over there wherever your NFC is located on your phone, and it will take you directly to the link. Sometimes you'll just have to hit accept or the browser that you want to pick. And I made one for learning to kind of help you learn how to use the unit circle itself. You also have different worksheets that are on that website. There's a video from Khan Academy that helped me a lot with kind of learning it and seeing the different things. And then on that top left one, or the second quadrant, I actually did an interactive unit circle digitally, and that one you can see how it moves simultaneously. You can see the sine, the cosines, you can see the tangents, and then you can on the bottom change where it tells you the names, the angles, the degrees, the radians. So it's a pretty neat little links that I added on there. So if you do get a chance to check out this part, it is pretty neat. So it should be with Professor Dillon. So definitely check that out. In conclusion, this right here is the source page. So without a source page and where we did the research, you're just making stuff up or copying and pasting off of Wikipedia. So this is where I got all my information from. The majority of the stuff that I really got a good understanding was from the Khan Academy. The videos, the articles, and then I had these sub things that I went through. For the actual model itself that I made, again, I did do that at the robotics lab in San Jac. And if you need to get anything printed there, it's an awesome thing to kind of go in there and talk with him and get some things printed out if need be. Also, with that in mind, it's really important to make sure that you do get the foundation with the unit circle and see how it works, because from here, everything definitely builds up when it comes to trigonometry, because you need these foundational things as far as seeing how these Pythagorean identities and how the different things kind of work, and then everything kind of evolves from there. So it is a very important concept to learn, because going further, if you don't have this kind of down and learned, it is a little bit more difficult. So that is the interactive unit circle that I made. The visual. I also do have a paper that I did write. I believe that'll be available too for you to take a look at. So good luck on all your math endeavors and scholarly endeavors, and have a great day, night, morning.